So this tells us a spherical balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters per second. So first thing, express the radius of the balloon as a function of the time t. So I want radius as a function of time. So I'm trying to basically say RT. I want a function. Radius as a function of time. We know that the radius increases 2 centimeters per second. So if you think about what that means. That's not what I meant to put at all. Okay, so if I made a table, I'm going to put time, radius. So at 0 seconds, the radius is 0. After 1 second, the radius would be 2. After 2 seconds, 4. After 3 seconds, 6. After 4 seconds, 8. So what would be my function? How would I find my radius?
2t.
All right. B. If V is the volume of the balloon as a function of the radius, find V composed with R and interpret it. So, volume. Do you guys know volume of a sphere? Probably not.
PRT.
So this is a formula you don't have memorized. I would give it to you. So the volume is 4/3 pi r cubed. So what I'm asking you to do is, what would I replace my r with? 2t cubed. So 2 cubed is 8 times 4/3 will give me 32/3 pi t cubed. And the interpret it, what does this formula give me? This is the volume of the balloon at a given time. So if I said 3 seconds, you could plug it in and figure out how much air is in that balloon. Next one. An airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. Express the horizontal distance d in miles that the plane has flown as a function of time t. All right, so what's going on here? We have an airplane, so I'm very artistic here. Here's my airplane. And it's going over a radar station. Altitude, what's that? How high it is. So from here to here, we're going to say it's 1 mile. And then it keeps flying. Horizontal distance, that's my d. So I want d as a function of time. So basically at time 0, we have flown 0. In every hour, we drive 350 miles. So after 1 hour, it's 350. After 2 hours, it's 700. So forth. So I want distance as a function of time. What's my formula? How do we find distance?
350t.
Express the distance s between the plane and the radar station. So this is S as a function of D. What kind of triangle is this?
A right triangle.
Okay, so we know Pythagorean theorem, 1 squared plus D squared equals S squared. So how would you find S?
Plug in.
Well, if I just wanted to get S by itself in this formula. Okay. So S as a function of D is just the square root of 1 plus D squared. If you just put S equals, that's fine too. I'm just really stressing the function notation. Yes.
Why can't you just turn that into just 1 plus D since they're both squared?
Because we don't know what D squared is. So we can't say, we can't do like 1 plus D with the square on the outside because then you would have to FOIL. And so the only way the square root and the square would cancel if it would be if it was just one term under the radical. Okay. So I want S as a function of time. So I have a formula for S, but D is my variable. So if I want it in terms of time, I have to replace my D with my 350t. And we could square that, but I don't think I'm going to. I'm just going to leave it like that. Question? Why don't you guys read one and see if you can set it up. Alright, let's look at A at least. Did you get that one? What did you get? Okay. So, we want to talk about the volume. Volume. So if you think about this, it's circular and it has a depth to it. Okay, so that is a really not good picture. It's like a canister here, like a soup can kind of. So we have, that is still a horrible picture. But we know the depth here is a constant 1 inch. So volume is like area of the base times the height. So the base is a circle. What's area of a circle?
4 over 3 pi r.
That's a sphere.
That's volume of a sphere. Area of a circle?
R squared.
Pi r squared. So then volume is just area times area of the base times the height, which my height was just 1. So I want that to be in terms of t. So my radius is 1.5 t squared. You can write this in function notation if you wanted d of t. You could square this. 1.5 squared is 2.25.
Wait, so why wasn't it the other volume? Why is there 2 different volume things?
This is a spherical, so like a balloon, a round balloon. This is like a soup can. So we have different shapes. So like area of a soccer ball versus area of a can. So interpret it. What does this tell me?
That the soup can is something.
Growing.
So V is the volume, so this gives me the volume of the oil spill.
Is an oil spill now?
Yeah, I mean I used V. It's been an oil spill the whole time. I used
Not a
soup
soup
can.
can?
I used soup can to try to explain my drawing.
I don't understand that. How can an oil spill be looking like a soup can?
Well, it has a constant depth to it, is what I was kind of
Okay.
trying to get.
Okay.
The oil was spilled into a soup can. Just think about that.
So basically, it would allow us to find at any given point in time how much oil has been spilled. So a stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 46 centimeters per second. So express the radius in terms of time. What would that be? Because it said in terms of the time t.
Did we learn this?
You answered it the first couple times.
Yeah.
Like,
No, but now I don't get it. No, but those ones make sense, this one doesn't.
Okay, so basically we're trying to
It's
figure
traveling
out.
at a time.
Right, so it says, so at time 0 we don't have a ripple yet, okay? So when, I kind of flipped my
No,
card.
well, I understand how the equation works. I
Okay,
just don't understand why it's, never mind, it's fine. It's fine, it doesn't have to make sense.
that's concerning.
No, it's okay, it doesn't have to make sense.
Okay, I want to express area. What shape am I looking at? Circle. So area of a circle is pi r squared. So I'm asking you to give me the area as a function of r. Okay? So, can I change that to time? Area is a function of time. So what would I replace my r with?
416.
And you could multiply that out if you wanted. You could leave it as 46 squared pi t squared. Either of those is fine. You're basically just giving me a formula for area at a given time. And so we interpret that it's exactly what it is. It's the area of the ripple at a given time.